Hello guys. Let's quickly treat this question. There are diverse ways of which you can attempt it. You can use trigonometric substitution, but you can also use rationalization. Now, let's use rationalization because I think that's a very fast method. So now, if you have to rationalize, yeah, though I will still use if I don't want to bring in the arc sine standard integral, I'm still going to use trig to prove that aspect. But I think I can just bring in the arc sine standard integral. But before then, let's rationalize. This guy gave us what? Integral of what? Root 1 plus x, are we together? Over 1 minus x multiplied by 1 plus x over 1 plus x. Use that numerator to rationalize. So here we have integral of what? Root 1 plus s square over what? 1 minus s square. Difference of 2 square. 1 square minus s square, the denominator. So for the numerator, dx. So this guy gives us integral of what? Root 1 plus x square divided by root 1 minus s square dx. Here square cancel, so the question becomes integral of what? 1 plus x over what? Root 1 minus s square dx. Are we together? So at the end of the day, what are we going to get? So we can split the integral to give us what? Integral of 1 over root 1 minus s square dx plus what? Integral of what? X over root 1 minus s square dx. So we can split the integral into two that way. So let me clean this guy. So we have a standard integral for this, but let me prove it using trig sub. This one, I don't need trig sub for this, is kind of going to be easy. But let's solve this guy. Let's solve the first part. Here we have integral of 1 over root 1 minus s square dx. We are still coming to this second one. Let's keep it. So let's solve the first part. Integral of root 1 minus s square dx. Now, using trig substitution here, we are going to use x equals to a sine theta. Yeah, I think I've given us before. We have about 4 different aspects that some will use sine theta, will use sec, will use tan. It depends on which one you are having. Assuming this is plus, I think we are going to use cot theta here. So maybe in my next video, I'm going to focus on that trigonometric substitution aspect alone and treat you when to know which one to use. And let me put it this way. If we have now, you know that for the trigonometry identity, the first identity is sine square theta plus what? Cos square theta equals what? 1. Now, make cos square theta the center of the formula. Cos square theta equals what? 1 minus what? Sine square theta. You can see that 1 minus sine square theta has an identity, right? So since it has an identity, now compare 1 minus sine square theta with this. You can see that we can replace, do we get, it's just like an idea you can use to remember even though you don't need to count. So you can see that this thing looks like this, whereby our 1 is this. It can be a at times, it can just any constant. Here now, we can replace our what? S square equals to what? Sine square what? Sine square theta. Are we together? This one we are using a, but because our a is 1, so here we are going to use just sine theta, 1 sine theta. Assuming this is b, it will be b sine theta. So now, that means here, if s square is sine square theta, that means s equals to what? Sine theta. So that's where the idea comes from. I can also use cos theta because for this one, if you make sine square theta the center of the formula, you are going to get 1 minus cos square theta. So it's either you use s is sine theta or s is cos theta. So that's that for that. And one thing you also need to know about integral is that I may solve an integral question, you may solve an integral question, and we get different answer, and we are both correct. But how are we going to know that we are both correct? Is if we differentiate the different question, if it gives us the same answer, then we are correct. Like when you differentiate an integral answer, something that you integrate, if you differentiate the answer, and another person integrate same thing, he differentiate his own answer. If your answer are the same, that means the integral that you find in the first place are correct, even though if the structures are different. Do you get what I'm saying? So now. So here we have integral of what? 1 over what? Integral of 1 over root 1 minus sine square what? Sine square theta. Now, if s equals to sine theta, Then let's find dx over d theta. Dx over d theta will give us what? Cos what? Cos theta. Yeah, I think yeah. So that means let's make dx the third formula. Dx will give us what? Cos theta d theta. So instead of dx here, let's put what? Cos theta d theta. You know, here we have dx. So we've done the substitution. Now don't forget that initially 1 minus sin square theta equals to cos square theta from the first trig identity. Sin square theta plus cos square theta equals to 1. So cos square theta equals to what? 1 minus what? Sin square theta. So replace this guy with cos square theta. We have 1 over root what? Cos square theta, then cos theta d theta. Now, square cancel roots. Are we together? So square, this cos square theta, root cos square theta, square will cancel root. So here we have integral of 1 over what? Cos theta multiplied by what? Cos theta d what? D theta. Cos theta cancel cos theta. So what do we have left? Integral of what? 1 d theta. If you integrate 1, what do you get? You get what? With respect to d theta, you get theta plus what? Theta plus c. Are we together? You get theta plus c. So now what's our theta? You know initially you say x equals to what? Sin theta. That means theta will give us what? Theta will give us arcsine x. Are we together? So if you plug it in here, so the integral of this guy is what? Arcsine x plus what? Plus c. Are we together? Yeah. That's the first part, arcsine x plus t. Now, let's focus on this second part. No, once we arrive at our final answer, we are going to add them together. Now, this is the second break. We have integral of what? X divided by what? Root 1 minus what? S squared dx. Now, let's use sub. Now, the fact that I split them into two, I use strict sub for this. And since if you know this standard integral, you may not need to show how you get it. You can just plug it in direct since it's not the original question. So I can also decide to use strict sub for the question from the beginning without splitting it. And the structure of the answer might be different, but if you differentiate both back, I'm going to get that original question. Now here, let u be what? 1 minus s squared. Now differentiate u. The u will give us what? Minus 2x dx. Isn't it? If you differentiate du, if you differentiate this, you get minus 2x dx. You know, if you differentiate 1, you get 0. If you differentiate minus s squared, you get minus 2x dx. Make the s the center of the formula. Ds equals to what? Ds now is going to give us, I'm coming, that's du over what? Minus du over what? 2x. Is that clear? That's our dx. Now substitute back to this. So this one now we have integral. Now listen, if u equals to 1 minus s squared, let's make s the center of the formula. This guy, that means u minus 1 equals to what? Let's bring x squared to this side. So here we have what? S squared equals to, if s, 1 is left here before. If s squared comes to this side, we have s squared equals to 1. If u comes minus u. Do we get that? Or do I even need? Let me check. So, if you continue like this, it's going to be kind of complicated because it won't cancel. If the s is this, if we bring in the x back, we turn this to u. Here we make s squared. So here now s will give us root what? 1 minus u, right? So let's rewrite. Here we have x, we have root 1 minus u over root, our u is 1 minus s squared dx. What's our dx? Minus du over 2x. The question is kind of even more complicated than the original question. So this is what we should have done. Let our u be root 1 minus s squared, not just s squared. Let u be 1 minus s squared. Now, if u is 1 minus s squared, then du will give us 10. Let's rewrite it. U equals 1 minus s squared all into half. So du will give us half will come down. I want to use chain rule, shortcut for chain rule. 1 minus s squared, subtract 1. You subtract 1 from half, you have minus half, right? Multiply by the derivative of what is inside. This shortcut for chain rule, you can use your chain rule and just write it, you get it. Times minus what? 2x. This shortcut. So here, 2 will cancel this, isn't it? So that means here du equals to 1 times minus x multiplied by 1 minus x squared raised power negative half. Do we get that? Let's not forget this answer. We have sine arc sine x plus c. So because I want to use that space. Now, dx, don't forget dx, sorry, dx, okay, dx. Now let's make, so here now we have u, du equals to what? Minus x divided by, no, this negative, so it's coming down, divided by 1 minus, no, since it has power of 5, that's root, 1 minus s squared dx. The negative shows that it's coming down, then the half is the root. Is that clear? Now let's make dx the center of the formula. Before then, this can be written as minus x dx over what? Root 1 minus what? S squared. Yeah, minus x dx over what? Root 1 minus what? S squared. Now, if du is minus x dx, how do we make dx the center of the formula? Is there space here? Yeah. Okay, now we have du equals to minus x dx over what? Root 1 minus s squared. Cross multiply. Minus x dx equals to root 1 minus s squared du, right? That means dx equals to root 1 minus s squared du over x. Then the minus will be here. Do we get that? Root 1 minus s squared du over x. Now let's rewrite the integral. Let's rewrite the integral. Let's rewrite the integral. So the integral becomes integral of x. What's our x? Do we have x? Okay, let's leave it that way. X over root 1 minus s squared, which is u. We can replace it as u, but there's no problem. Dx, what's our dx? Minus root 1 minus s squared, which is our u, then du over what? Over x. Can we see that? S cancel x, root u cancel root u. So this question becomes, this negative can come out as a constant. Integral of what? 1 du. If you integrate that, what do you get? You get u plus c. Minus is outside. Minus u plus c. Minus u plus what? Plus c. Now add it to this one. You know it's addition. Then do our final answer now. Integral of what? Root 1 plus x over 1 minus x equals to what? Arc sine x plus, but because there is minus, minus u. What's our u? Root 1 minus s squared, then plus c. That's the final answer. I hope that's clear. Yeah, thanks for watching. Drop your view on the comment section. Let me see if it is well understood. Since this is going to be on my channel membership, let me know your mind. Then I will tackle whatever you have. Thanks.